Welcome to Marina's Powerhouse Team Review Center. Okay, so we are discussing the single-phase system. So let's have the part 2 of the single-phase AC system. So AC components. So this is our part 2. Let's go over with our discussion. Okay, we have components of AC circuits. So we have resistance or well, of course, what is resistance? No, from DC circuit, it is the opposition offered by a resistor to the flow of current. Okay. Then we have the reactance, X. So, property of inductor or capacitor to oppose the current flow in the given circuit. So, inductive reactance, so we have here our X sub L is equal to 2 pi FL. No? So, this opposes, no? Kumbaga kontra siya, no? Okay? So, kontra siya sa daloy ng kuryente natin, no? Yung inductor. So, meron siyang property doon, no? This is what we call the inductive reactance. That is the opposition by the inductor to the flow of current. What about now for the capacitor? We have the capacitive reactance. That is equal to X sub C, that's equal to 1 over 2 pi FC. And take note that this is our 2 pi F, that is our omega. That is our omega. Or the angular velocity. No, that is the omega. Okay? So, we have the impedance. Okay, we have the impedance. That is the total opposition of the circuit presence to an alternating current. So, by Ohm's law, remember, there is also Ohm's law in AC circuit. We have our Z that's equal to V divided by I. Just like in Ohm's law in DC circuit, we have the resistance that is V over I. Okay, so in polar form, so let's have our triangle. No? So, let's have our triangle. So, our triangle, we have what we call the impedance triangle here. Okay, so we have here our theta. Okay, this is 90 degrees. Okay, so this is impedance Z. This is our resistance. This is our reactance. Okay? So, our Z is equal to the magnitude of Z, okay, bar angle or cis, no? In some professor would call this symbol as cis, as C-I-S, no? Cis, no? Pag may cis ba, may bro? Oh, cis, okay ha? Okay, magnitude of Z, cis of plus minus theta, no? Plus minus theta, okay? Yan, that is the polar form. What about in rectangular form? Our Z, that's equal to R plus minus JX. Okay? JX. That is in rectangular form. Again, no, I have to, sorry about this, no, plus minus J. That is in advanced engineering mathematics. Sir, where did you get that? Okay. So, that is in being studied in advanced math. That's very long discussion, no? Sorry, I cannot discuss that today, no? Okay. But I can give you a bit of idea, no? Here. So, take a look here. We have here our X. If we have here positive JX, meaning it is X sub L, automatic. If we have here negative J, X, meaning that is a capacitive reactance, inductive reactance. Okay? Okay? So, we have here the phasor. This is the resistance. This is the resistance here. And then you have here on the positive direction, so this is our positive J, X sub L. We have on the negative side here, this is the negative J, X sub C. Okay? Remember, if it is positive J, that is X sub L. No? That is inductive reactance. Paki-close up, partner. Close up mo pa. If we have here negative J, we are referring to the capacitive reactance here. Okay? Capacitive reactance. Okay po ba yan? So, ganun, ano? So, let's continue. Okay, so, if we have here a positive theta, from the Greek alphabet theta, we mean inductive or lagging. So, we will discuss this later. What is inductive? What is leading? Okay? So, let's have first this. If we mean positive theta, this is theta from the Greek alphabet. No? So, we mean inductive. Inductive. If we mean negative theta, we mean capacitive. Just like this one, guys. Just like here. If we mean positive J, we mean inductive. Inductive. If we mean negative J, we mean capacitive. We mean capacitive. Okay? So, let us continue this one. Behaviors of resistance, inductance, capacitance in AC circuit. For pure resistive load, if we have a pure resistive load, the current is in phase with the voltage. What do you mean by in phase? In phase is they have the same starting point. They have the same starting point here. This is the voltage waveform, the bigger one. We have the current waveform, the smaller one here. So, the average, the P average is B sub M, I sub M divided by 2. No? The I is I sub M sine omega T in ampere. Let's say. That is the equation. Okay, I will discuss first the three types of load or electrical load. Or shall we say, three types. Three types of power factor. Okay? Three types of power factor. By the way, what is a power factor? Power factor. From the triangle first here. So our power factor simply equal to cosine theta. So that is equal to adjacent, which is R over Z. R over Z. Okay? Just have to get the cosine of this theta. The three types of power factor. Number one, we have what we call the resistive load. Resistive. Resistive, or shall we say resistive or unity power factor load. Just like you have an oven, a toaster, you have an incandescent bulb, you have your flat iron. No? So, these are your resistive load or unity power factor load. So, we have here, take a look at the waveform. Let's say this is the voltage waveform. Okay? And this is our current waveform. There you are. Okay? So, as we read this as I is in phase with B. I is in phase with B. They have no phase difference. They have the same starting point here. Let's say at 0 degree. Okay? Sir, why is it called as unity power factor load? Because power factor is equal to cosine theta. What is cosine theta? There is no phase difference between them. 0 degree. What is cosine 0? Unity. Okay? Therefore, number 2. Number 2, we have what we call the inductive load. The inductive or what we call the lagging power factor load. What do you mean by this? So we have here, let's say, we have our voltage waveform. So ito yan. This is our voltage waveform. Okay. Then our current waveform is this, let's say. That is our current waveform. So this is the starting point, no? So we have here our theta. That is the phase difference. You see this one? The distance between two starting point is what we call the phase difference. That is the phase difference. Okay? So there is already an angle here. Let's say 30 degrees, 45 degrees. There is already an angle here. As we read this, this is I. This is I lags V by theta. Tandaan natin yun, ha? I lags V by theta. Sir, when is it lagging? The current. When is it lagging? When it is leading. Take a look here for capacitive. Let's see the difference between the two. We have here inductive, so this is capacitive. Or we have what we call leading power factor load. Okay? Let's see. Remember, if we have resistive load, of course, you have a very high resistance load. You have inductive load, you have inductance, high inductance load. You have an inductor, I mean. Of course, leading or capacitive load, there is a presence of capacitor here. Let's say for synchronous motor, no? Or synchronous condenser, or let's say there is a building, you have a capacitor banks in your building, so there's a tendency that that will become leading, that will have a leading power factor. That's a possibility. That is overcompensation. Anyway, we have a discussion about power factor correction. We have a separate subject for that. So, let's say this is our voltage. This is our voltage V. That is our current I. Here. So, ito yung current I natin. Remember, our basis is the starting point of the waveform. Okay? Again, this is the starting point for I. Okay? This is the starting point for B. So, ito Yan. Ito yung starting point natin, ha? So, ito siya. So, this is our phase difference. That is already the phase difference between the two. See? But, sir, when can we say that current is leading or lagging? When? Okay. This is my technique. You say the two starting point. Take a look this shape. You see this shape? Do you remember something with this shape? This is the shape, let's say, of a head, no? Side view. Let's say you have the two basketball player here. This one. Take a look here. Take a look here. One. Let's say this is the head of LeBron James. Well, of course, you know LeBron James, no? So, this is the head of LeBron James. This is the head of Stephen Curry. You see the side view, right? Side view. They're running each other, right? They're running. That is the side view. Okay. Let's say this is the finish line. Who is nearer with the finish line? Is it LeBron James or this current is Curry? Current. You see? Let's say this is Stephen Curry, the current. Which is nearer head? Sino mas malapit sa finish line? Of course, LeBron. This one, the head of LeBron. You see, there is a head here. No? Nearer to this finish line. Stephen Curry, no, nahuhuli siya, no? If we mean lags, nahuhuli yon, no? It lags. If we mean lead, you are in front, no? This is the finish line. Then you read this as I leads B by theta. I leads B by theta. If we mean I leads, meaning you have a leading power factor. Leading power factor. If we mean I lags, meaning you have a lagging power factor. Therefore, the power factor will dictate the nature of the current, not the voltage. Remember that. If we mean lagging power factor, lagging current. If we mean leading power factor, leading current. You see? So that's the idea of these three electrical load. So let us consider this. Take a look here for problem number 3. Let us solve number 3 problem. Okay, if the voltage represented by B is equal to 140 sine omega t is connected to a non-inductive resistance of 8 ohms. Okay? So meaning this is non-inductive, meaning this is purely resistive. No? Calculate the maximum value of the current. The frequency of the applied voltage is 50 hertz. Okay? I think this is an easy question. So the question is calculate the maximum value of current. Let's say this is our I sub M. Okay, by Ohm's law, this is our B sub M over, okay, for this case, no, the only opposition is the resistance. Okay, so just put here R. This is a non-inductive resistance. So we just have to substitute what is our B sub M, that is 140. 140 then divided by 8. So what is the answer? So you just have to divide. There are some board exam problem like that. Just have to divide. 140 divided by 8. So the answer would be 17.5 amperes. Okay, the answer would be letter. Okay, so anong letter sagot natin? Okay, letter B. That's the answer. Okay, let's go now with this, no? Okay, for pure inductive load, no, the current lags the voltage by exactly 90 degrees. That is 90 degrees, meaning the distance of the two starting point of this waveform is 90 degrees. The average power for inductive load is 0 watts. 0 watts. Okay? So, our I, this is our I. So, this is what? Sine omega t. This is minus 90 degrees. So, you have this one. Minus 90 degrees in ampere. Okay? Because the starting point here is on the right side. No? It's already on the right side. That is why this should be minus. Okay? So, that is minus 90 degrees. Okay, so let us continue this. Wala. Ayaw. Umaga. Dito lang. Okay. Okay, let's solve now number 4 problem. Punta tayo sa number 4. A coil of negligible resistance has an inductance of 0.01 Henry. A voltage represented by 140 sine omega t is applied to it. The frequency being 50 Hertz. Calculate the current flowing through the coil. So, we are asked to find the current flowing through the coil. Okay. So, again, so we have a negligible resistance inductor or inductance. So, you have an inductance here. Okay. So, may inductance tayo dito. Then, we are given here a voltage source. This is the voltage source. Okay. So, our L is, how much is that? 0.01 Henry. 0.01 Henry. Okay. So, voltage represented by, so we have our voltage V here. No? Of course, our V here is much. How much is this? 140, no? 140. Then we have here sine omega t. Supply. The frequency being 50 Hertz. So, 50 Hertz. Calculate the current flowing through the coil. So, we are asked to find the current here. Well, of course, our current, no? Our current, again, so this is our B sub M over X. Anyway, this is inductor, that is our X sub L. Okay? Let us get first our X sub L. So, kunin muna natin yung X sub L natin, no? So, ang X sub L natin, ano yung formula natin kanina? Our formula is 2 pi F L. 2 pi. What is our frequency? So, we have 200. We have 50 Hertz. We have 50. Then, our L is 0.01. 0.01 Henry. So, we have here 2 times pi times 50 times 0.01. So, well, the answer is simply pi, no? Or 3.14. Okay? So, actually, in my calculator, so that is just pi, no? Of course, approximately, that is equivalent to 3.1416, right? So, we have 3.14. That is our X sub L. Okay? That is our X sub L. Okay, now, so we have here our X sub L. Again, we said that our X sub L is above, no? So, that is, in the Cartesian plane, our X sub L is always above, no? Here. That is actually positive J X sub L, isn't it? Okay? The one below is negative J X sub C. Then again, your 0 degree is always your resistance. That will be your reference vector. Up to power system subject. If we mean reference vector, meaning it is 0 degree. Always remember that. No? Parating 0 degree po yan. Okay, let's go first with the basic. No? So we have here I sub m. We have B sub m. How much is B sub m? Okay, so we are given 100. Take a look here. We have here 140 sine omega t. So if we are going to convert this into polar form, that is 140 bar angle 0 degree. Okay? So let us put here 140 bar angle 0 degree. Okay? What about our x sub L here? What about our x sub L? Our x sub L here is simply pi or 3.14. Okay, so we have here our x sub L, no? So, take a look here. That is a positive J, which is equivalent to positive 90 degrees. That is 90 degrees, right? This is 90 degrees. This is 0 degree. This is 90 degrees. This is negative 90 degrees. The x sub c. So, we have to put this as what? X sub L, positive 90 degrees. Okay. So, if we have here our I sub m. So, this is two polar form. Okay. In polar form, in advanced mathematics, no, ito na naman, advanced math. So, you just have to divide 140. Remember this, ha? 140, just divide it by 3.14. How much is that? Okay, I have here 44.59, no, to round it off, no, if we are to round off this one, 44.59. 44.59. Okay. Then what about here? In advanced engineering mathematics, so what you will do here is, you see, you have your 0 here, 0. If we are dividing, always remember, if we are dividing, you have to subtract. 0 minus 90 degrees. Remember that. You have to subtract. Okay? But if you are to multiply, no, you have to add the two. What do I mean? I'll give you a little idea about this. Let's say you have 100 bar angle 40 degrees divided by 20 bar angle 10 degrees. Okay, for the benefit of our technicians here listening, I know engineering, especially fourth year, fifth year, even graduates, no, more so for graduates, this is easy for them. But I will not only cater this student, these guys, no. I want to cater also our technicians. If we are to divide this one, so of course this is that will become 10 over 2. That will become 5. That will become 5. Okay? And what you will do here, if we are dividing, so that will be 40 minus 10. You have to subtract. Ganon. Hindi mo siya di-divide. So, subtract mo siya pagka angle, no? So, the answer will be 40 minus 10. So, that will become 30 degrees. Okay? That will become 30 degrees. Then, if you are to multiply, let's say I will multiply these two. We have 100 bar angle 40 degrees. Okay, paki-close up. We have here 20, 10 degrees. So, multiply mo muna to. 20 times 100. So, that is 20. 2 zeros, 1, 2. That will become 2,000. What you will do in the angle here, if we have to multiply the two complex number, the two phasor, or polar form, I mean, that should be 40 plus 10. You have to add the 2. So you have 2,000, 40 plus 10. So you will have what? 40 plus 10, you will have 50 degrees. Okay? So, in here, that is 0. It's just like saying the angle is negative 90. Just the same. Okay? Negative 90 degrees. But, if I will convert this, we have here 44.59. So, that will become sine omega t. That will be minus 90 degrees. And remember, that 90 degrees is equivalent to pi over 2. Okay? So, we have here 44.59. Then we have here sine omega t minus, so we have here pi over 2. So, that will be our final answer here. Of course, the unit is in amperes because this is our I sub m. Or shall we say that is our I, no? That is how we represent. We may call this as our I. Small I, no? Kahit small I na lang na tawagin natin to, small I. Okay? Because I sub m is this value. This value. Ito yung I sub m kasi natin, di ba? Yung maximum value. So our answer would be letter. So what is our answer, partner? Okay. Natin ang sagot natin. Letter, tama ba? 44. Okay, that's correct. No? That is our answer. Nearest to letter B. Okay? Let's have number 5 problem. Okay? So, this will be the last problem that I will going to solve, no? Okay, but first, I will discuss the pure capacitive load. The current leads the voltage by 90 degrees. So, you see, nauuna, no? I leads. Okay? If this is the finish line, always on the left side, okay? Sino mas malapit, no? Nearer. Current is nearer to the finish line. Okay? So, therefore, I leads B by 90 degrees. Again, the average power for pure capacitive load is 0 watts. Always remember that only resistive elements consumes watts. Resistors, only resistors consumes watts. I is I sub m sine omega t plus 90 degrees. Sir, why is this positive 90 degrees? Because this is on the left side of the xy plane. Again, this is positive, this is negative. Baliktad siya. That is opposite with our Cartesian plane in algebra. Okay? In algebra, this is positive, this is negative, right? But in AC, it's different, no? It is the exact opposite. This is the positive, this is negative. So that should be positive 90 degrees. Okay? Next. Okay. So number 5 problem. A voltage represented by 150 sine omega t is applied to a capacitor of capacitance 24 microfarad. The frequency is 25 hertz. Calculate the maximum value of current. Okay, again, so we have a pure capacitor here. We have a voltage. Okay, so the question here is the maximum value of current. Again, our maximum value of current is maximum voltage over X sub C. Well, the maximum voltage is already given to be 150 volts. What about our X sub C? Our X sub C is 1 over 2 pi FC. So we have here 1 over 2 pi. What is our frequency? How much is this? 25 hertz. Then our capacitance is 24 microfarad. So that is 24 times 10 to the negative 6 in your calculator. So in your calculator, you have to press your times 10 raised to x in your calculator. That is besides the ans button, no? The button below here. Okay? The button here. Okay? So let us have this one, guys. Okay, 1 divided by 2. Well, there are so many ways, no, so that you can calculate. But for me, what I'm doing here is any scientific calculator will do. So just press 1, then divided by 2. Then you press again divided by pi. Okay? Okay, so of course, for you to have pi, so you press shift, then times 10 raised to x, right? So there you have your pi. Then another divided by. So puro divided by lang. 25. Another divided by 24 times 10 raised to x. Yun yun, ito yun. Okay? 24 times 10 raised to negative 6. There. Then equals. So our answer here is 265.258. Okay, make it 26. Now, that will be in ohms. That is our x sub c. Okay? That is our x sub c. Well, there are so many ways. So the other student will do first, they will multiply this, then 1 over x, no? No problem about that. Okay, so we have here, our b sub n is how much? 150. That is our given. Then our x sub c is 265.26. 265.26. So this will be our final answer. So we have here 150, then divided by 265.26 equals 0.566 0.566 amperes. That is our answer. So that will be letter. Okay, partner, anong sagot natin? What is our answer? There you are. So our answer is letter D. Okay? So that is our topic for AC circuits. Okay. So thanks be to God, mga kawerpa. No? Thank you